right. To start off our parametrics unit, we're going to go ahead and start with vector review. I'm not sure if you've had vectors in pre-cal or not, but if you haven't, at least this kind of gets you started, like what is a vector and in our parametrics unit. Okay, so first off, what is a vector? It is a directed line segment. Okay, such that it looks something like this. All right, it has, let's say this is P, let's say this is Q. All right, so right here at like the dot, this is called our tail. All right, which is our initial point. All right, where the arrow is, this is the direction that it is going. All right, and here, this is our terminal point. Now, it may still keep going on. The arrow says the direction it's going, but terminal, a lot of times it'll end and it'll have like the actual ending to it in length. All right, vectors with the same length and direction are equivalent. All right. Okay. So let's get started on some problems just to review some of this. Let's let vector PQ be a vector with P at 1, 2 and Q at 4, 7. Find the terminal point of the equivalent vector with initial point at 0, 0. Okay, so here we've got P at 1, 2. We've got Q at 4, 7. All right, the initial point we're going to call just X1, Y1. All right. And the terminal we'll just call X2, Y2. All right. And what we do to find it is we would do X2 minus X1, and then we would do Y2 minus Y1. All right. And by the way, as far as vectors, we use these V things on the side. All right. So for here, this is our terminal. This is our, or I said that backwards. This is our, P is our initial, Q is our terminal. So we do the terminal first, 4 minus 1, and then we're going to do 7 minus 2. All right. And so we end up with the vector 3, 5. All right. Since the initial now is 0, 0, then the terminal point, okay, will be, and when we write a point, we write it in parentheses. And it's going to be the same thing, 3, 5. Like that. All right. Now, a few things about vectors themselves that you may want to copy down, put in your memory bank. A vector whose initial point is 0, 0 is in standard position. And in standard position, the vector can be represented by the coordinates of the terminal point, which is kind of like what we did here when we actually found that vector. All right, this is called the component form whenever you have the V's on the side of our vector. And vectors in standard position are named with one lowercase bold letter V. And sometimes they'll do like V, sometimes they'll do U, and you're going to see it through here, but it's with lowercase letters to name the vectors. All right, moving right along. Find the component form of the vector with an initial point, -2, 3, and a terminal point, 4, -1. So here's our terminal, here's our initial, we're doing the same thing. So it's 4 minus -2 and 3 minus -1. All right, and so I end up with 6, 4, and there we go. And this would be the component form with these vector things on the side. All right. Now, so that's kind of like the same problem that we just did a second ago. I did throw some negatives in there. All right. So just be careful about that. And I actually did this incorrectly because, and be careful of your order. You want to do the terminal first, which I did here, but then when I did the Y value, I did not. So really, this comes out to be -4. So -1 minus 3. Sorry about that. All right, the length of a vector is called its magnitude, and it's denoted, magnitude is denoted as like this with these double bars right here. Okay, so when it talk about magnitude, that's what we're talking about. And the formula for magnitude is, say, vector 1 squared plus vector 2 squared, and that equals our magnitude. And so we'll find some of that here. And it's actually the components of the vector here. So here, say I want to find the magnitude of u. All right, well, we're just taking the square root, and it's just -1 squared plus 5 squared. And it's very similar to like Pythagorean, part of Pythagorean theorem, things like that. All right, so this is square root of 26. And we'll just leave it like that. We can't reduce that radical or anything. All right, number 4. Given vector AB with A being 2, -4, and B -1, 0, we want to find the magnitude of this. All right, well, we're doing a combination of what we did in the beginning, where, all right, and notice this, it didn't actually say terminal side this side at time, and it didn't say initial. So A is going to be our initial, B is going to be our terminal. All right, so I've got to do -1 minus 2, and then I have to say 0 minus -4. All right, so that gives us -3, 4. All right, so this is our vector now that we want to find the magnitude of. So the magnitude of AB, all right, is going to be -3 squared. Make sure if you put this in a calculator, you put it in parentheses, although we should know what -3 squared is. So this is 9 plus 16, so the square root of 25. This one does reduce, and so the magnitude of this vector is 5. All right, so here, now another word for magnitude is length. All right, length equals magnitude. Okay, so I'm gonna denote it like this. Okay, so we can use those interchangeably as well. All right, moving right along. The direction of the vector is the angle theta that the vector makes with the positive x-axis. And you'll kind of recall this, and if you kind of actually think about unit circle, doesn't that start on the positive x-axis? All right, so if I want to find, and by the way, we always give the angle as a positive number less than 360. Okay, that's one of the things whenever we talk about this angle right here. We also, just for this unit, now in calculus, we always keep everything in radians, but we're reviewing vectors. So remember to change your calculator to degrees, but then change it back to radians for the remainder, because anything we actually do calculus-wise, it will be with radians. Now, what we're going to do is find the direction of this vector. So we're going to look at the vector u -1, 5. Okay, so let's graph this kind of like we're graphing it on a coordinate plane. Well, where is -1, 5? Okay, there we go. Okay, and then the vector is going to be like right here. All right. Now, let's think about this for a second. So theta is going to be this value right here. All right. And think about this. So we're finding the direction of it. All right. We're finding the degree. We're going to find theta basically right here. Now, what can we make here? If you're thinking right triangle, and let's put it right here, just because I drew it a little long. All right. Okay, this x value is at -1, the y is 5. So here, this is a length of 1, this is a length of 5, correct? And we just created a right triangle. All right, well, how can I find this x right here? Okay, think back to math 2 when you did like just angles and triangles and so forth. And how do we find that angle? Think about this. This is the opposite side. This is the adjacent side. What's opposite and adjacent? tangent. So tan of x equals the opposite, which is 5, over the adjacent. Okay, well, now how do we find this right here? X equals tan inverse of basically 5. All right, now I'm going to throw in and actually use Desmos on this. All right, make sure, like, practice using the College Board one just to make sure that you understand it and know all the features. Okay, so here we go. Tan inverse. Don't forget, inverse is underneath these functions thing here. There we go. There's tan inverse of 5. Now, again, remember what I was talking about? You need to be in degrees. So here right now I'm in radians. So hit this wrench and I want to do degrees right here. Okay, so here we go. So if you notice, it's 78.690. 78.690. All right, and then now that's what x is. So how am I going to figure out theta? It's just 180 minus that right there. Okay, and when I come up with that, all right, that's going to give us theta. All right, so theta equals, if I were to throw it in, I've got it sitting right here. The degree of theta is 101.31. And let that make sense. We know in the first quadrant that's 90, and then it's going to go a little more. So yes, that value does make sense for that. All right, so we're going to do the same thing, but we're going to do it here. Notice 3, -4. This is a little different. 3, -4, 1, 2, 3, 1, 2, 3, 4 is going to be like right here. Okay, we can still make a right angle, but make it with the x-axis. And this time theta, think going clockwise, this is theta right here. All right, well, this is a length of 3, this is a length of 4, if I put x right here. Okay, so the tan of x equals 4 over 3, opposite over adjacent. Okay, opposite of that side is 4, adjacent is 3. Okay, and again, we use tan inverse. So tan inverse of 4/3. Okay, so here we go. And actually, what we can do, and actually, let's just play around with this. Because it's negative, you probably actually do want to put a negative right here. All right, so here we go. We didn't necessarily have to put a negative here. Just play around with it. So tan inverse, -4/3. Does that make a difference? All right, so it's negative 53 is really what it is by putting the negative. If I take the negative off, it's just 53. Okay, so if you do happen to put the negative, it's okay, but it just means x is 53.130. Okay, so how am I going to figure out what theta is? Because this is all the way around, 360 minus 53.130 is what theta is going to equal. All right, and when I do that, that's 306.87 degrees is what theta equals. All right. Okay, moving right along. All right, let's look at number 7. All right, again, we're still looking and recalling vectors. All right, vector AB with A being 1, -4, and B 3, 5. So we're doing the same thing, except for this time, they actually give us 2 points, basically, the initial and the end point. So what we've got to do is we've got to do 3 minus 1, and then we have to say 5 minus -4. Okay, and so that's going to make 2, 9. All right, and now we can go on and actually solve it like we just did the other two. All right, so 2, and then 1, 2, 3. Okay, is going to be right here. All right, here theta equals x. So when I do this, the tan x of 9/2, and I do inverse tan of 9/2, that is going to give me theta this time. All right, so pulling up. Let's see, what do we say? 9 over 2? 9 divided by 2. All right, 77 point, just making sure, hold on. Yeah, 77.471. All right, degrees. All right. So now let's look at some vector operations. Some of these you're going to be like, well, duh, just need to go over them just so that you know. When we're adding vectors, we're like literally adding the vectors right here, given u and v. So we would add -2 plus 3, and we would add 5 plus 4. And it comes out to be 1, 9. Okay, so we can straight up just add vectors. Same thing with subtraction. Okay, just be careful of the order that you're doing it in. So -2 minus 3, and then 5 minus 4. So this vector is -5, 1. Now here we have a scalar. You can multiply a scalar in. So 3 times -2 and 3 times 5. All right, that's going to be -615. All right, and then here we can just do a combination of all of that. 2 times, and I'm just going to go ahead and do 2 times this in my head. So that's 6, and then that's going to be 8, minus 3 times, which actually we just did, -615. So when I subtract them, 6 minus -6 is going to be 12. 8 minus 15 is going to be -7. All right, so straight up operations, like you thought they probably would be. All right, number 12. Find the vector in the direction 45 degrees that has a magnitude of 1. All right, well, what does this mean? Well, we were just talking about degrees just a second ago. So 45 degrees is going to be here. But what do we mean by magnitude of 1? Well, remember earlier we said magnitude is the same thing as length. So length right here. So we just have to find the vector. Well, think about finding x and y here. All right, what do you remember? And this is one of those triangles that you should remember when theta equals 45. So it's a 45, 45, 90. What is x and y here? All right, square root of 2 over 2, square root of 2 over 2. Now, if you don't know that, the way that you could do this is we could say the cosine of 45 degrees and then the sine of 45 degrees. All right, and those are square root of 2 over 2, square root of 2 over 2. All right. Find the vector in the direction 240 degrees. All right, so I had to figure out where 240 is. All right, all the way to here is 180. All right, all the way to down here is 270. Okay, so that's a little too far. So 240 would be somewhere in here. Okay, well, think about that for a second. If I take 240, all right, and I minus, so 240 minus 180, that leaves us with 60 degrees. And what that means is this is 60 right here. All right, well, guess what? I made a right triangle. Always make it with the x-axis. Its magnitude is 4 right here. Okay, now when the magnitude is 1, we can straight up think unit circle, because think the radius of that circle is of the unit circle is 1. All right, here we can kind of think that, except for we have a 4 right here. Okay, now here's one thing. So this is 240 degrees. Okay, well, you can think about this for a second. Whenever you have a 30, 60, 90 triangle, think about it for a second. Across from 30 is 1/2. Realize because it's here, that's going to be a -1/2. All right. And then this right here across from 60 is square root of 3 over 2. And again, because it's in the quadrant, it's actually both of them are negative. All right. So the magnitude would be -1/2 and then -3, 2, or the vector, sorry. But then I would multiply it by 4. So when I do that, I get -2. All right. And then -2 squared root of 3. Okay. Now, if you can't remember your unit circle, all right, again, what you could do is you could say 4 cosine of 240 degrees and 4 sine of 240 degrees. That's another way to do that right there. All right, and it'll give you the same answer. However, when you plug this into your calculator, the problem is it'll come out as a decimal since we got a radical. So just in case, if you want exact, you got to remember your special right triangles. All right, moving right along. A unit vector is a vector with magnitude 1. We actually just saw that in number 12. All right, now find the unit vector in the same direction as -3, 4. Okay, so let's look at it. -3, 4. So 1, 2, 3, 1, 2, 3, 4 is going to be right here. All right, now we can find the magnitude. Okay, so same direction. Okay, find the unit vector in the same direction as -3, 4. All right, so we've got to find the magnitude first. Well, magnitude is the square root of -3 squared plus 4 squared. Okay, and I believe we actually did just do the square root of 25, which is 5. All right, so that means the magnitude of this one is 5. All right. And think this was 3, this is 4, so forth. Well, when we talk about a unit vector, this now needs to be 1. Okay, now think about it. How can you get this to be 1? Well, you would divide by 5. Okay, so we would take basically this vector right here. Okay, we'll call that V. Divide by 5 or multiply by 1/5, and that's going to give us the unit vector. All right, so here it's going to be -3/5, 4/5. That is our unit vector. Okay, so think about this taking that value to 1, and what do you need to do to get it to 1? So in number 15, same thing, find the unit vector in the same direction as 2, 5. All right, I like to draw pictures just so I know where I'm at right here. Okay, so like this would be 2, this would be 5. First off, you have to find the magnitude that it is right now. So think Pythagorean theorem. So 2 squared, 5 squared, then you would take the square root. All right, so 4 plus 25 is square root of 29. All right, so think about this being the square root of 29. How do you get that length to be a unit, to be 1? Well, I would divide by the square root of 29. So, or multiply by your vector by this 1 over the square root of 29. So when I do that, I get 2 over square root of 29 and 5 over the square root of 29, like that. And that will be our unit vector. All right, number 16. Find the unit vector in the direction 30 degrees. All right, here, unit vector 30 degrees. We know 30 degrees lies right here. And when the unit is 1, all right, 30 degrees, think about it for a second. That's 1/2. 30, 69 triangle, square root of 3 over 2. All right. So therefore, it's just 1, or actually put the x first. So square root of 3 over 2, and then 1/2. All right. Or if you didn't know that, it's the cosine of 30 degrees, sine of 30 degrees. All right. Now I do, and I'm just going to pull these and just explain these right quick. Some word problems and just kind of walk you through what I've got on my page. All right, say we have an airplane flying in the direction 65 degrees east of north at 500 miles per hour in still air. It encounters an 80-mile-per-hour tailwind acting in the direction 35 degrees east of north. The airplane maintains its compass heading, but because of the wind, acquires a new ground speed and direction. What are they? All right, so I'm going to walk you through this. Okay, so we've got this one. They tell us here it's in the direction of 65 degrees and east of north, 500 miles per hour. So the 500 is actually the magnitude, the length of it. All right. And when it said east of north, think about it. North is here. And if I go east, it's this. So that's really what 65 degrees right there. Theta is going to be right here. So to find theta, we do 90 minus 65. And so this angle is 25 degrees. All right. So if you think about it for a second, think about creating your right triangle right here. All right. Well, how am I going to find this value and how am I going to find that? All right. And remember, it's 25 degrees. Now, 25 isn't on our unit circle, so this is where I would plug it in. It's the magnitude times the cosine of 25 degrees and the magnitude times the sine of 25 degrees. And so I get this. All right. So this is the vector of our airplane. Okay. However, we have a tailwind. They tell us our tailwind is 35 degrees east of north, okay? And it's 80 miles per hour. So it's 80. All right, really my theta is here, so that theta 90 minus 35 is 55 degrees. All right, and I can find this vector just the same way I found this one up here. It's going to be 80 cosine of 55, 80 sine of 55, and I get these two values. Again, make sure you're in degrees because I'm using degrees. Now, because the tailwind, because it's a tailwind, the resulting vector, what we're going to do is we're going to add them. Because if you kind of notice, they're going like in the same direction. So a tailwind is going to push you and make you go faster. So what we do with these two vectors that we've got is we add them. All right. Now, we still haven't answered our question. We want to find direction and the speed. All right, so we've got our new vector is what we came up with. Here's our new vector right here. Okay, now to find the direction, that means theta. All right, think opposite, adjacent. So tan, and we did this earlier, and we did inverse tan. Okay, and you get 29.019 or just 29.02 degrees. So that is the direction. Now, as far as the speed, that's the magnitude. That's when we take the square root of, say, your x value squared and your y value squared, add it together. All right, so our speed is 570.685 miles per hour. So that tailwind actually makes it go faster. All right, and changes the direction a little bit of this airplane. Okay, now let's look at another one right here. An airplane must actually fly due south at a constant ground speed of 675 miles per hour against a headwind of 60 miles per hour blowing in the direction 15 degrees east of north. What direction and ground speed for still air must the pilot maintain to stay on course? So this is actually the same thing, except for I gave you a headwind this time. All right, now when it says due south, like it literally is going south. All right, and so theta is 270 degrees. And right here, 675 and is miles per hour. So that's the length. And if we think about this, cosine of 270 right here is 0. All right. So that's why when you multiply these, you get 0. Here, the sine of 270 is -1. So -1 times 675 is -675. All right. So this is the vector of just the airplane. All right. The headwind, it tells us it's going 60 miles per hour, blowing in the direction east of north. Okay, so 15 degrees east of north. That means this theta is going to be 75 degrees. Okay, so to find the vector of the headwind, it's 60 times the cosine of 75, 60 times the sine of 75. And when I do that, that's what pops out. Okay, because it's a headwind, so I've got one going south and one going this way, it's pulling against it. So the resulting vector, what we'll do is subtract because it's a headwind. All right, and when I subtract these, I get this as my answer. So you do the plane and then you do, and if you think about it, the plane's going faster. All right. And the other one's just tugging behind on it. So I did 0 minus this right here, and I got negative 15.529. Here I did negative 675 minus this right here, and I get that value right there. Okay, now, so here is the resultant of it. All right, so to find theta, here's my two values. That's where I use tangent. All right, inverse tan, and I get 88.786 is what this theta is right here. Now, remember, that's what theta is in the triangle. I would have to add 180 onto it. And that's where I get 268.786 degrees. All right, and so that's my direction. And then my speed is this value right here in miles per hour. All right, and now actually for some calculus that goes along with these vector problems. And we'll get into more calculus as we go through this unit. But again, this is just setting us up with vectors. All right, what are they? What are we talking about? And so forth. Okay, so let's look at this. A particle travels in the plane with position vector r of t. Find the velocity vector and the acceleration vector. Okay, well, think of the r of t as your position vector. Actually, it is your position vector. Okay, and think about it. What do I need to do to find our velocity vector? Okay, well, we take the derivative. Oops, the first derivative, not second derivative. Okay. Okay, and that would be 16t plus 18t squared, not plus. Don't put plus. All right. Okay, and now if I want my acceleration vector, I would take the second derivative. All right, and so that's going to be 16, and then 2 times 18 is oh, 36 t like that. All right. Okay, and then we can actually do it again. So don't forget all your derivatives that we've got. So you notice I picked out some tan and the cosine. Okay, so for my velocity, I'm just going to say r prime right here. Okay, what is the derivative of tangent? And don't forget, guys, I know it's been a while. Make sure you do what's it called? Chain rule. Okay, in this. So here we go. And now that I'm looking at my examples, I see that I've got something that's incorrect right here. What is the derivative of tan? It is secant squared, but don't forget to put 3t right there. You keep the 3t, and now you say, what's the derivative of 3? Or 3t, it would be 3. Okay, here the derivative of cosine is negative sine, so it's negative 3 sine t. Okay, and then for our acceleration vector, all right, it is the second derivative. All right, so we got some chain rule going on here. All right, so here, you're going to have to think of this as being 2 is to the second power. So we would deal with the power first. 2 times 3 is 6, and that's going to be secant of 3t. Now, what's the derivative of secant? All right, the derivative of secant is secant tangent. And 3t's are with each one of these. Now you take the derivative of just 3t, and that's going to be 3. So I will times it by 3 right here. And I'll clean this up in just a second. All right, and now I'm going to go down here. So now this one's a little bit simpler. Negative 3 sine t, derivative of sine is cosine. So this is going to still stay as negative. Like that. Now I can clean this up. So that vector is going to be 18. Now notice I have 2 of these. So secant squared of 3t. All right, tangent of 3t. And then I have the negative cosine of t. All right, so don't forget your derivatives. Don't forget chain rule. If you have to use quotient rule, this is going to be a good time to review any of those things that we did in AB and all of your derivatives. And eventually we'll look at integrals too of certain things as well. So before we go into our AP exam. All right, study up on this and we'll continue with parametrics and vectors and so forth with this unit.